Okay, so we start with vector A first. Remember, its angle is with respect to the horizontal. So we know vector A, the angle here is 15 degrees. And the length of vector A is 13 centimeters. Then what does the person do?
Down.
Yeah, down and left. South, west. South means down, west means left, so down and left. But now we need a new horizontal. Remember, every time you get to like a pause in the diagram, you need a new horizontal. So draw in a new horizontal here so we can label this angle appropriately. This is vector B now, and vector B's length is 10. What was the question?
No.
You sure?
No.
Take a look at the angle now. See where the angle is drawn. It's not arbitrarily drawn there. It's drawn there for a specific reason. So the person starts here, right? This would be west. So this is north of west. 15 degrees north of west. Then this would be west. So this is 20 degrees south of west.
So when you're connecting the different vectors, the degrees apply to the horizontal.
Always, 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 yeah? Remember, whenever you get to a point where the person kind of stops for a second, draw a new horizontal, and then that angle is with regards to the new horizontal every time. So here they started, so this was our horizontal line that goes through it. So this is 15 degrees north of west. Well, this is 20 degrees south of west. Well, what's west? West is this red line, the horizontal, okay, on the left side. So we drop south of west at 20 degrees. Then from here, what does the person do?
Straight north.
Straight north from there. So let's draw a vector straight up from there. And that's vector C, and its length is 8 centimeters. So in reality, which way is this person going to end up moving? Give me a directional. From beginning to end, which way are they going to move? Northwest. Make sense of that, please. Okay? They're going, again, west, and then north. Obviously, they're going northwest, southwest, and north. But in reality, what's happening, if you took the right triangle from here, you go straight across, and then straight up to where you ended, and then connect it. So our goal is going to be to find this weird-looking resultant. Okay? Now, to do that, remember, all you need to do is find the horizontal components of each vector, add them up. Find the vertical components of each vector, add them up. That will give you the resultant vector components. So remember how yesterday we talked about a horizontal component, you use cosine of the angle, vertical component, use sine. So here, for this first one, we're going to find its horizontal component, which is like the base of the triangle, and the vertical component. Then we're going to go to the next one. Find the horizontal component, the vertical component. And then the last one is only vertical component. You're going to add together all your horizontals, add together all your verticals separately, and that will give us the overall horizontal and the overall vertical, enabling us to find the overall result.
When it goes vertical, do not need to add a horizontal.
Correct. No horizontal, because everything's in the vertical that way. And you could do cosine, and you could say, all right, cosine of 90 degrees. But the cosine of 90 is 0. So it ends up making the horizontal just 0. So you could technically include it, but you will get 0. Okay? So let's take a look now. I'm going to minimize this for a second. Hold on. Can you still see the numbers at the top? Everybody has the diagram written down? Okay. Can you see the numbers? What's important right now at the top up here? I don't even need the diagram. By the way, I drew the diagram so you guys can see it. I do not need the diagram at all. And I'll explain why you don't need the diagram. We can do this all with trig or all with math.
On a test, though, would you ask for us to be able to draw a diagram?
It might help you, but if you don't do it and you do all the math right, I'm fine with that. Okay? So let's look in the x components first. And then we'll look in the y components. So look at vector A. The length of vector A is 13. The angle that it moves or directs at is 15. But we're going west. Remember the x-axis is like this, right? This is positive, the x-axis. This is. So what do I have to do for my horizontal component? What do I have to call it? Call it negative. So the first part is going to be a negative motion in the x direction. And it's going to be, remember, the vector length times the cosine of the angle. That's the horizontal component for vector A. Again, remember yesterday in the diagram it was called AX. It was A with a little subscript of X. That meant the horizontal component. So we are literally determining the length of this segment right here. From here to here. That's what we're determining. We're calling a negative to indicate the person moving to the left.
Does it matter if the negative sign is like inside or outside the parentheses?
I put it outside to indicate that the motion is to the left. Makes no difference. Okay? How about vector B? Vector B, its x component. Again, with vector B, are we moving to the left or to the right? Say again? Because it's moving to the left. Again, vector B is moving down. We don't care about it because that's the y version. We'll see that in a moment. But for the horizontal component, it's moving left. So it's another negative for vector B. So vector B is going to be another negative here. The length of vector B times the cosine of its angle. Again, they're both negative because both vector A and vector B cause this person to end up left of where he or she started. Okay? When your final position is left of where you started, your displacement is clearly negative. So that's it for the x component. Why am I not considering the third vector again? It's only in the y. It's only a vertical component. It's north. It's not northeast. It's not northwest. It's only vertical, so it's only a y component. So that's it for the x direction. So let's write down the y direction now. Vector A. Is vector A moving up or down? Vector A is moving up, so it's positive. Even though it was negative here. Remember this was negative, guys? Because it was moving left, but it's moving left and up. Up indicates positive in the y direction, so put a positive here. Or just, you have to write anything because it's positive. And instead of cosine, sine. Sierra?
So it's like, for the horizontal, you look at it the horizontal way, and then for vertical, you look at it.
Right? Vector A's length is 13 times the cosine of the sine of its angle, which is 15 degrees. Remember, it's the length of the vector times the sine of the angle. Length of the vector, sine of the angle. Remember, this is the x component of vector A. This is the y component of vector A. These are both vector A. So 13 goes twice. Remember this, and I can write it out if it helps. Remember, this is really negative ax minus bx. This is really ay, and we're going to have again minus by because it goes back down, and then plus c. We're going to see that in a moment. Remember, ay is positive because a causes the vector of the person to move up. Vector b, though, vector b goes southwest. Here direction. Southwest. South is down. So vector b is going to have a negative sign in front of it for the y component. So let's put a minus sign here. So we have a minus 10 times the sine of 20 degrees. And use logic, right? Use common sense. If this person starts to move up and then they move down, you have to have opposite signs at some point, right? They move up and then down. If they move left and then right, there need to be opposing signs somewhere. In this problem, the person moved left the whole time. And finally, what do we do for vector C? What do we do, Katie?
Would you take 20 plus 90?
What direction is vector C acting?
Just plus 8.
Only north, so
Plus 8.
it's just plus 8. Because all of vector A is north, isn't it? So we're not finding the component. Vector A's vertical component is vector A, because it's all north. So for this one, we're going to add 8. Okay, again, the vertical component of vector A acting north. The vertical component of vector B acting south. The vertical component, or the only component of vector C, which is all vertical, acting north. All we have to do is add these together. When we add them together, here's what we're going to get. We're going to get the length of, and I'm going to draw it in blue, okay? This, when we add the x values together, is going to be that right there. See that blue line right there? The sum of these two x values is the length of that blue line. Maybe in words we should be like jotting this down, right? So this, I'll underline the X in blue so you know that that's indicated there. In purple, we'll have the Y component, which is really measuring this length right here. That's what we're doing. We're creating these small components that can be added together to give us an overall right triangle. And that's represented by the blue base and the purple height. The purple height is the sum of the Y's. The blue base is the sum of the X's. Go ahead and type this in your calculator, please. Do X first. So we've got negative 13 times the cosine of 15 minus 10 times the cosine of 20. Emma?
I have negative 21.95.
Others? Agreed? Negative 21.95? Check if your mode is in degree to make sure. If you did not get that.
I got negative 21.
Let me see your hit mode real quick.
Oh, that's right.
Yeah, negative 21.
I got negative 20. I thought you said negative 25.
Ah, okay. 0.95. If you didn't get this, please let me know real quick. Did anybody not get that answer? Express one, please. So 13. So parentheses. So negative 13 times the cosine of 15. Line of parentheses, you have to close it. So minus 10 cosine of 20. Okay. After you type in the angle measurement, you have to close your parentheses on the calculator. Okay, I'm glad you brought that up, so. Okay, you have to close your parentheses on the calculator. Anyone else not get negative 21.95?
No, I got it.
What, in the y direction?
Yeah, I got negative 0.05.
Did you forget to add 8?
Did you-
Yeah, I did.
So
7.94.
7.94.
Wait, do you add all those or do you?
You do whatever it says. So you do 13 times sine of 15 minus 10 times sine of 20
Yeah, yeah.
and add 8 to the end of it.
Okay.
Right? You guys, you can do this all in one line in your calculator. Don't do this in separate lines. Do it all in one line in your calculator. Okay, all in one line.
Did you add 8?
Probably forgot. No, I did. Or use the parentheses.
We had to.
Wait, put minus 8 again instead of plus 8?
What's that?
Maybe you forgot that.
Oh, never mind.
Is that at least correct? Can people verify? Yes?
Yes.
All right. You didn't get these?
No, I got it.
You sure?
Yeah.
Anybody not get these?
I was just keeping negative 8. It's so unnecessary.
You do it all in one line? I can tell you right away, it's fun. 13 sine 15, okay? You add a parentheses before sine 15 and then close it. Look, you have one open, and only one closed. So you can insert another parentheses, and you have minus 10 and sine of 20.
Thanks, man.
So another parentheses, plus 10. Okay?
I'm gonna eat.
Second, enter, so I can see what you typed. Second, enter.
Yeah, it was in
You did your number 7 then? Okay. You have a 10 sine 15, which is number 4. You see 10 sine 15 right here? So you can use that at the end. You can see that right there. Do it all in one line, please, Kate. Do it all in one line.
I like my hand for something. Mine doesn't work.
13 goes 15. See your open parentheses right there? Your open one is special. Did you ever close it? Did you close that parentheses? Okay, you don't really need parentheses around it, so if you want this
You
here,
can do that
you
too?
don't really need it. You can do it like that.
What I need to print.
If you open another one here, you need to close it. Everyone you open it, close it. So because you put one before the cosine, then you put one after here, close it. leave it like that. Minus 10. X goes times 20. Is this the X component or
No,
Y
it's like one of
component?
my favorite.
Oh, well, yeah, I do.
What's not parts?
I
But I think it just makes no sense.
I love that.
So you're doing the top, right? So you need to put a negative sign in front of yours. That is negative 13.
Maybe it's not really a second.
Oh, you did plus 8.
Yeah, but we're
If you're doing the X component, you don't need the plus 8. So then you're doing the 1.95 on the left. If you're doing the Y component, what you're going to do is this. You're going to put plus 8 on the end. This is changing the sign. That was negative. The one in the front was positive, right? Hey, fun fact, listen carefully. A lot of you don't know this, and I realized it. You could press second enter to bring up the last command you typed in, and then instead of rewriting all this, you could have just kept the X direction the way it was, got rid of this negative sign, so it's positive, changed this to sign, left this alone, changed this to sign, and go to plus 8. But it takes like a fifth of the time to do it. I just did all this in about 10 seconds. You need to practice it.
I have to go back.
You can also just, oh no, never mind, that works on my phone.
You definitely need to practice it though. You definitely need to practice quickness with
You
this.
could also just go up in like the row and then just press enter and it'll automatically copy it over.
That's what second enter does. That's what I was telling them. But you have a different version. That's why.
I have the
All right. So now listen carefully. The X direction is negative because we're moving. The Y direction is positive because we're moving. That makes sense, right? Think about the diagram. Without that plus 8, though, without that plus 8, this would have pretty much been 0, wouldn't it? So the person would have done this and come back to the same horizontal level they started at. But the plus 8 caused us to do this. So our goal in this problem is not to find just the components, but the resultant, which is the hypotenuse, isn't it? So let's find the hypotenuse length of this. This is the base. This is the base. This is the height. A squared plus b squared equals the hypotenuse squared. So our goal, again, is to find, I'm going to connect it with a red line here. Find the length of this, and I'm drawing in right now. Okay, you see that red hypotenuse there? Your goal is to find the length of that red hypotenuse and the angle. Not, see how it says 15 degrees there? That angle is not necessarily going to be 15 degrees. We don't know. That was the angle from earlier. So you're not using this 15 degrees. You need to find that angle also. Okay, look at the diagram where I crossed out 15. That's the angle you need to find. Find that angle using tangent, opposite over adjacent. Find the hypotenuse using Pythagorean theorem. I'll write it up. Notice that my negative is inside the parentheses. If you forget to do that in the calculator, you're not going to get the right answer. And I draw parentheses around everything to be safe, but when it's positive, do I really need the parentheses here? No. Okay? I do not need those parentheses. So square them, sum them, square root them. Square them, sum them, square root them. Somebody else that hasn't answered something yet today. Square them, sum them, square root them. What do you get for R? What does R equal? Zoe? 20.5? I feel like it's going to be larger than that. Did you put your negative inside the parentheses?
Wait, I got first year 23.
Give her a sec. Hold on. Let her fix it. You know why I knew that, Zoe? The hypotenuse has to be longer than both of these, doesn't it? So 20 doesn't make logical sense. It's got to be bigger than 21.95 for sure. Your answer cannot be less than that number. It can't be less. It can't be less than 21.95. You could drop the negative when you do Pythagorean theorem, or just make sure that it's inside the parentheses. But either way, when you square a negative, it is positive.
I got 23.
Yeah, 23.
Frank? 23?
3.34.
Yeah.
That's what we got.
That's what we.
I got 20.
Yeah, I got 23.
Okay, great.
So we'll just do 0.3. Be nice, man.
I got
23.3. Okay? Now, we need the angle. Remember, the angle that we're looking for is always the angle between the vector of resultant, or resultant vector, and the horizontal. So, see where 15 is crossed off in the diagram? Look at my diagram at the top. That's the angle you're figuring out all the way up here. Okay? Where the 15 is itself crossed off. I forget that I have this pointer sometimes. So find that angle, please. The angle between the vector, that is the resultant, and the horizontal. How do I do that? Using what function? Tangent. So, the tangent of theta, which is what we're looking for, equals the vertical component. And remember, we care about the actual value, not the direction here. Okay, we're looking at an angle. So what we're going to do, and I didn't really go over this last class because it didn't come up, but we're going to use the absolute values of these. So I'm not going to include the negative there. Okay, notice what I'm doing here. For a triangle, we're literally looking for the angle measure. If I leave this as negative here, I'm going to end up getting a negative answer, which simply means in this case that it's going to end up going to the left. But it's not what we're indicating. We want to know the geometry of where it's going. And the geometry behind it is definitely positive. The length itself is a positive length. So please use positive numbers whenever you do this. Write yourself that note right now, because we did not talk about this yesterday. So write a little note that when you find the angle, you should use the absolute value of the lengths of those triangles. How do I get theta as a result? I use the tangent inverse to get theta. And you don't really need to write absolute value in your calculator, just put the positive number instead. Just remember to put the positive lengths only. Positive lengths because we're looking at geometry. We already know that it's going to be northwest. We knew that from the diagram, so we don't even need to include the fact that the 21.95 is negative. We've already accounted for it by saying west. Okay, and our answer is going to say west. What do we have for this one? What do we have? Theo?
19.886. So just 19.
I'm going to use 19.9. Can others confirm that? Yeah? Good.
I did not get that.
No, I know. Here, did you?
Yeah, I did tan first.
Second tan
And then what? And then 7 point. Yeah.
over 21.95.
Oh, I closed the parentheses before I did that.
That's it. Because you're taking the tan inverse of this whole thing.
Right, okay.
Okay? So, our final answer will be written as 23.3. 23.3, what was it, centimeters we started with?
Yeah.
At 19.9 degrees northwest. So this person could have accomplished the same thing that he or she accomplished by moving northwest, then southwest, and then north, simply by doing this right here. Follow this bearing. On a boat, you go to bearing, right? Okay, follow this bearing with this directional. That would have accomplished the same result as what we did by going up and down and then back up. Questions at all? So over the weekend, you're going to make sure to finish this, right? The homework and practice this?
Yeah.
Okay? Now, when we use this in section 3.3, it's actually a lot easier than what we've been doing. In section 3.3, when we utilize this knowledge, it'll be easier than what we're going to have to do here. But I still want you to be able to do this because you have to know directionals and displacement. But when we utilize in 3.3, it's not as difficult. Okay? So let's go ahead and open up 3.3, please.